Hello all, and welcome to chapter 5. Today we're going to talk about elasticity of demand. We also could talk about elasticity of supply, but everything in this chapter, since we haven't introduced the supply curve in detail, is really related back through to that demand curve, right? So first off, what is elasticity? Elasticity is just going to tell us about the relationship between prices and quantities, or quantities and income, or quantities and the price of another good, right? And so what we're really looking at are items that can shift that demand curve or items that can change the slope, although slope's a crude way of saying it, but change the slope or rotation along an axis of the demand curve, right? So make it steeper, make it less steep, right? Or shift it in or shift it out, right? So it's a fairly simple concept, but there's a lot of let's call it tedious bookkeeping math, right? So the equations are longish, but really it's just about managing the equation and putting in the right pieces and then solving for the missing variable, right? So the math isn't challenging, it's just more likely you're going to screw up a direction or something like that. But without much ado, let's just go in. So we'll start with these learning objectives that you all can read on your own. So feel free to pause so that you can catch these. Hopefully I'm leaving enough time here. So we're going to cover these mathematical concepts, and we're going to talk about how you calculate the change in quantity and the change in price in terms of measuring elasticities. For those of you with a better math background, a lot of this is going to look like the midpoint slope formula, right, for some of these calculations. And you'll also notice that if you try to use YouTube and search other videos, your textbook has an interesting variation. In fact, I'm going to spend some time really quick erasing my whiteboard. I don't want to use this whiteboard too much, but we can pause the share for a little bit. And I'm going to show you what other textbooks do, right? So how other, most economists or many economists are thinking about elasticity, mainly because that's the way I learned it. And I view it as easier than the formula that they're giving you. But also, I just want you to know when you look up something, there are different ways to do math, right? So there is no one right way. And you'll get the same answer, regardless you use the books method, you use the method that I'll show you. But we're going to go through it the books way. So some of the key concepts covered, we're going to cover own price elasticity, which is just the change in the quantity of beef consumed for a given change in price. So we're going to say how sensitive is quantities of demand for a change in price, right? So I'll give you an example. If beef goes from $5 to $2 a pound, do you think more people are going to purchase it? The law of demand says yes. As price goes down, quantities demanded go up, right? So this is just how we're going to measure this. Income elasticity, we're going to look at the change in the quantity of beef consumed for a given change in your income. So the more wealthier you are, do you consume more beef or do you consume less, right? Really could be either way. Cross price elasticities, here we're looking at shifts in the curve. So the prior two, we're looking at how steep the curve is. Here we're going to look at a shift. So we're looking at our good substitutes for each other. So we can think about the example we're going to use is ragu and Hunt's, right? Spaghetti sauce. Those can substitute one for the other. Maybe some people say no, but is what it is. Or are they complements? They're things that you consume simultaneously. So like hot dogs and hot dog buns, which we talked about last time in the last chapter. We're going to look at arc elasticity, and those cross price elasticities is just measuring the change in the quantity of your primary item divided by the change in price for another item that you can substitute or complement out. Or you might find out that there's no relationship, which means that we'll see mathematically equals zero. There's no relationship between the two, or close to zero. So arc elasticity just represents a range along the demand curve. It's one method of calculating elasticity. We also have point elasticities, which is a point on the demand curve. We're just making a point estimate. And then price flexibility is a term that just refers to the reciprocal of the own price elasticity. Remember in reciprocal where you have like the number 2 over 1, which is equal to 2, the reciprocal of that is 1 over 2, which is 1/2, right? So we're really looking at price flexibility in terms of being the opposite, I guess we'd say, of own price elasticity, right? So let's move on. So own price elasticity of demand is measured simply by doing the percentage change in quantity divided by the percentage change in price, but getting those percentage changes is a little convoluted using the math, right? So when we want to do this, we could represent it by that second equation, change in quantity divided by change in price times the price divided by the quantity. And if we're doing that, we've got these formulas for substituting in. So our P bar, see the bar over top of the P in these equations, that we're going to substitute in the price after a change plus the price before the change divided by 2. So we're just taking the average or the midpoint of those prices. And then we're doing quantity is just the average quantity, QA, the quantity after the change, plus the quantity before divided by 2. Once again, it doesn't make a difference in these equations necessarily which one goes first because you're adding. But here it does, and we want to be consistent. So change in quantity is going to be QA divided by QB, and the change in price is just going to be simplistically PA minus PB, right? So once again, A stands for after the change, B stands for the price before the change or the quantity before the change. Hey, the bar over the P and Q variables indicates an average or a midpoint, right? So we're looking at that average once again. Add the numbers together, divide by 2. So we're looking for a specific range on a curve, right? So we're measuring between 2 points. And really the way people screw up this problem is, one, they forget the formula, right? It shouldn't be a problem in an online class since you're all capable of writing it down before you take an exam or work on the problem set so you can look it up. So that's not going to be as big an issue for you. The next way people screw up this is they get the PA and the PB backwards, right? Or the QA and QB backwards, and they start missing up the variables. So it's very important to keep organized to make sure that your PB represents your QB and your PA represents your QA when you're pulling the numbers, right? When we're actually using data instead of using just letters and symbolically talking about it. The other thing to note is we're only measuring the elasticity between these 2 points, which means it might or might not, it probably will change as we go up or down the curve. The elasticity tends to change along the curve, right? There might be some special case where it doesn't, but we won't get into that. So how do we interpret the result? Once we've got some numbers on a graph and we've plugged in the data and done the calculation, we're going to get a number, and what we're concerned about is 1. That's our kind of delimiter. So if we find that our elasticity of demand is greater than 1, then we say that the demand curve or the demand for the product is said to be elastic. One way of thinking about it when we get to the graphs and we're looking at the change is that change in quantity is going to be greater than the change in price. So if the price goes down a little, you're going to buy a whole lot more. If the price goes up a little, you're going to buy a whole lot less, right? That's what's happening. And we're really there, we're looking for greater than 1. If we have something that's less than 1, then it's an inelastic good. What that means is your percent change in quantity is less than the percentage change in price. So that means your price goes up a little bit and your quantity barely budges. So what we're really getting to there is what we call an inelastic demand curve. And in its pure case, what we're really saying is price doesn't affect the quantity. You have to buy it when it's inelastic, if it's purely inelastic. And when we're thinking about that, think about the few things in life that you have to buy. You have to buy certain drugs that keep you alive if you're sick, if you have a disease or a syndrome. You have to buy water, right? You're not going to live very long. You have to buy food in general, right? Now, within food, it could be more or less inelastic, but food as a group is very inelastic. Price of food goes up, people still need to eat, they might cut back a little. Price of your medicine goes up and it's the pill that keeps you from dying, you're not going to change. You're going to keep buying it unless you can't afford it, and then you're dead, right? So, and then we've got this last concept of unitary elastic. There's no economic meaning for unitary elastic. It's just the dividing line. In fact, I always like to say, look, what's it mean to be 1.01 versus 0.99? Is there really a difference? And I'm going to say they're both pretty much unitary elastic. I don't know where the cutoff is, where we're way larger than one or way less than one where we become elastic or inelastic. But I know that generally around one, there's no real economic meaning, right? So we can say when something's elastic, that it's not something you need, it's something you want. When something's inelastic, it tends to be something you need. There's other things that determine elasticity. Your book doesn't do a great job of getting into this discussion, so I'm not going to require you to know this, but needs versus want, whether an item's a luxury good, right? Luxury goods are those things you need or those things you want. When we think about the time, so your elasticity of demand is related to time. So if all of a sudden we go to war with Russia and Iran simultaneously, and oil is embargoed and it gets difficult, the price of gasoline spikes. Well, tomorrow you might use the same amount of gas you use today. You're going to try to cut back. But by 30 days out, you're going to have found a way to not use gasoline anymore, right? So the longer you have to make the change, the more elastic something becomes. The more abrupt the change, the more inelastic the demand is at that time. Then another thing is share of the budget. How much do you spend on the item? The argument normally is that the more you spend on something, the easier it is to give it up. And so it's less elastic or more elastic. And if you don't have a lot of something, then it's more inelastic because we're presuming that it's, since you don't have it, you might not have replacements, right? So, anyway, but that's share of the budget, right? So how much you do. And there's a few other features, but those are the big ones I wanted to touch on. Anyway, out of breath. So these are all examples of demand curves, right? So they all are going either perfectly vertical or they've got some slope that is negative to them, right? And then we've got this perfectly horizontal one that's lower in there. So we have two special cases. The vertical curve is perfectly inelastic and the horizontal curve is perfectly elastic, right? And these are special cases. And so the way to think about, once again, perfectly inelastic is we don't care what the price is, we purchase the same amount. In the most extreme experience, we're thinking about medicines that keep you alive. Perfectly elastic means that you are completely sensitive to price. If the price goes up, you consume nothing. And if the price comes down, you still consume as much as your budget allows you to purchase. Not a lot of pure examples of that, right? But maybe there's a few, but anyway. But yeah, perfectly elastic means you're just very sensitive to price, right? That price goes up, and this is probably a good that has lots of substitutes. So you're like, oh, okay, well, I could have that Hostess, but if the price goes up, I'll just switch to a candy bar. Maybe one example. Here we have a steep slope. The slope here is going to be less than 1. And that means that we're inelastic, but not perfectly inelastic. And here, the slope is going to be greater than 1. So not perfectly elastic, but just elastic, right? So it's something, another variety. So notice I said, as you move up or down the demand curve, you end up changing the elasticity using the arc elasticity method normally. And so when you're higher on the curve, as represented by higher prices, that means you have more elasticity. When you're in the middle, you tend to be more unit elastic, and when you're lower, you tend to be more inelastic because your quantity change is going to be less than your percentage change in price. You'll give up more. So if we look at this table, we can notice where unit elasticity exists. And what unit elasticity really means is that there's just a change 1 for 1. So if price goes down 1%, then you're going to buy 1% more. If price goes up 1%, you're going to buy 1% less. And even your book is kind of cauterizing this idea that, if we're close to -1, and notice all the own price elasticities are negative, that should make sense because negative is a demand curve, right? The demand curve is inversely related. It's negatively sloped. And so we would expect the calculation result in a negative sign. A lot of economists and textbooks leave the negative sign off of elasticity of demand. So if you don't do it, just people acknowledge and know that it is a negative. So sometimes textbooks don't even throw that in. So I like to point that out in case you end up taking an economics class later in life and you're wondering, why does this textbook not show negative signs, right? And my old one did. So anything greater than 1 is elastic. And, all of these are pretty clearly greater than 1, except maybe this part right here. Then we've got our unit elastic portion of this demand curve, and then we've got our inelastic demand portion. So when we add in these prices, when we've got an elastic curve, the way I like to think about it is let's put a rubber band around this quantity change and around the price change. And let me go back. So what we're saying is the price changes a little and the quantity changes a lot. That's when we're talking about elasticity, right? We get this really large, stretchy quantity in terms of a smaller price cut. And so the cut in price brings about a larger increase in the quantity demanded for this particular demand curve. So then the question is, what happens to producer revenue and what happens to consumer surplus when we're dealing with elasticities, right? How steep the slope of the curve is. And, well, we'll just track through some of these changes. So in this case, producer revenue is going to increase because the revenue before the change was PB AQB, anyway. So PB, 0 PB. God, I hate the way this present this. Sorry, guys. So let's kind of take a step back. Once again, revenue for the producer is just price times the quantity that they sell, right? So we can imagine that we've got this PB line to the demand curve, that curve C, and we go down to QB, right? So we've got PB and QB, and that price times the quantity is how much revenue we have. And so it's that rectangle, that really tall rectangle. When we lower the price, we give up some price, but we get a whole bunch of quantity. And so we can see for an elastic demand curve, the revenue is higher after the price changes than before the price changes, right? The area from PA to the blue line down to QA and 0, that big square rectangle area, is much larger than the area of the taller rectangle, right? And really, let me change this before I forget. That really should be PB times QB. QB and the revenue after change PA times QA. Yeah, definitely some formatting issues from this publisher. So is what it is, but there we go. Okay, and so we're shading those spaces that I already talked about. So let's go back kind of further. Okay, so we've got these changes. It's kind of funny. I guess I need to change it on all the slides or something. I have no clue. Anyway, I'll try to figure that out later to add in the times again. Okay. So once again, the tall rectangle is going to be a lot smaller than this big square. So what are the revenue implications? This table just presents a little summary. So if a good is elastic, then you cut the price, it's going to increase revenue. If you increase the price, it will decrease revenue. If something's unitary elastic, there's no change in revenue, right? It's just going to be 1-for-1 swap. If it's inelastic, then you cut the price, you're going to decrease revenue. You increase the price, you're going to increase the revenue. And that should make sense. It's steeper curve. And, we should get a slide showing this with the steeper curve later on, hopefully. Okay, what was the consumer surplus before? Our consumer surplus was small at a higher price. After the price cut, we get this larger triangle, which represents a larger area for consumer surplus. So you've got PA to C to point B out here on the hypotenuse. Okay, so the gain in consumer surplus is going to be the gain of that larger triangle and subtract out the smaller triangle, right? And so numerically, we could calculate the area of both spaces, subtract the one from the smaller triangle from the larger triangle, and we should get that total area. Or we could use another method, calculate the area of the square from A to PB to PA. in that small square, and then we could calculate the area of the triangle from QB to QA and B to A, right? So two different methods of calculating that gain in consumer surplus. So here's our example with the inelastic curve. Once again, we see the similar size price change. Price goes down and we barely get any more quantity sold, right? The demand quantity just doesn't go up a lot. And so what happens to revenue and consumer surplus again? Well, we get this tall rectangle and we look at the small one, and I think you can see that the area we gave up is less than the area we gained, right? So we end up with producer revenue going down as the price falls, right? No reason to lower the price unless the market's dictating for this producer. The consumer surplus is going to increase by area PAB. So question, how do we calculate that? I would calculate the area of the square and the area of the triangle personally. Okay, characteristically, agricultural goods are represented by inelastic demand for their products, right? And that's just because agricultural goods represent things that we need, right? Now we might substitute one good for the other, but agricultural goods as a group are fairly inelastic. Not perfectly, but fairly. So this bottom row, or the bottom row, is really what we're going to be focusing on for most of the class, is steeper demand curves. And those steeper demand curves are going to mean that revenue cutting the price will decrease revenue, increasing price will increase revenue. And once again, we're going to have a change in consumer surplus. And all likelihood, we're just not going to gain enough consumer surplus to justify the price change, right? Consumers aren't going to get benefit hugely, just like producers won't. Or maybe they will. We'd have to do it case by case, take the numbers. So here's some examples of retail-owned price elasticities that exist. We can see beef -0.6, cheese 0.3, milk 0.4. Beer is the only one that's going to be greater than 1 at 2.2. And why would that be? Well, are there a lot of substitutes for beef? Chicken, seafood. If you're a vegan, vegetable protein sources, soy. But there's not a lot, it's not a very large group. Same for cheese, same for bananas, same for milk, same for fruit. What about beer? Whiskey, ciders, malt beverages, liquor, wine, lots of other options for beverages, soda, juice, things like that. So once again, most of what we're concerned with is inelastic, but there are some elastic agricultural products as well. So let's take rice as an example, which has an own price elasticity of demand of 0.1467, means this is something that people need. So this measure suggests that if the price of rice drops by 10%, the quantity of rice demanded would only increase by 1.467%, right? So pretty useful metric in terms of making this relationship. So how do we measure income elasticity of demand? Now it's going to be percentage change in quantity divided by the percentage change in price. This indicates a potential change or shifts in the demand curve as consumer income changes. I'll let you guys pause and kind of work through the math and put the substitutions in. But I think this is a good place for me to write out the way other textbooks show it, since I can do it for the other one. But you can kind of back end into it. Or actually, let's take a step back. We can do it this way. So let me draw our share. So if we're going to do income elasticity of demand, that is going to be equal to Okay, so I'm back after having drawn it out. That way you didn't need to wait for me to draw out. So what you can see on my board is that the incoming elasticity of demand is just equal to the change in quantity, which is Q2 minus Q1, divided by the average change in quantity, Q1 plus Q2. And the Q2 is just your Q after, your QA, and your Q1 is just your QB or your price before. So the new price minus the old price. Take the new and the old, divide by 2 to get your average, and you divide that whole expression by the change in income. We're going to use Y for income, which is just equal to your after income, your new income minus your old income, and the average change in your income, right? So this is just another way of presenting that same type of formula, that same type of information. You'll get very close approximations on both methods, right? So whichever method you choose to use, whatever's easier for you will work. But that's the substitution that occurs. So let's go back to doing our screen share real quick. Okay, so here, once again, we're looking at shifting the curve, not changing the slope of the curve. And the idea here is that as your income changes, how much do you change your quantities that you're looking to consume? So if your incoming elasticity is greater than 1, then, and it's going to be a luxury good and a normal good, right? If you're less than 1 but greater than 0, then you're a necessity and a normal good, right? And if it's a necessity, we would expect to see an inelastic or a more inelastic demand curve. And if we're less than 0, then we're talking about inferior goods. And these are goods that I hate to say they violate the law of demand. And I actually have maybe a little different way of putting that out there, right? But anyway, inferior goods are goods where they pretty much violate the law of demand. As price goes up, you choose to consume more, right? We tend to think about goods, agricultural goods during famines as being inferior goods. The quintessential economic example is the Irish potato famine. Because potatoes were the cheapest food, even as price of potatoes went up, people still consumed more of them, right? Because all other food items were just even more expensive. Just another way of thinking about it. Okay, so cross-price elasticity of demand. This is for substitutes or complements, right? Goods we consume together or goods we substitute out for each other. We look at the percentage change in quantity of one good, divide by the percentage change in price of another. I'll leave it to you guys to insert all of these out and create the big formula. But we're just looking at the change in the quantity of H divided by the change in the price of good T times the price of T divided by the quantity of H. And this is going to indicate, once again, a change or a shift in the demand curve as well, right? So income price elasticity changes and shifts the curve. So does cross price elasticity. And if the cross price elasticity is positive, the goods are substitutes. If it's negative, they're complements. And if it's 0, there's no relationship between the goods. It's keeping it fairly simple there, folks. So an example, comparing Prego to Prego, we're looking at these blue values being the own price elasticity or the price elasticity of demand. Sorry, let me grab a drink. So that's just how the good itself responds to a change in its own price. Now, Prego, Ragu, and Hunt's, in case you don't know this, are 3 different types of canned tomato sauce that's available in the grocery aisle for the purpose of spaghetti sauce, right? So Prego for Ragu is 0.51. That means that these goods, if we go back to our prior slide, the number is positive. And so they're substitutes. You substitute Prego for Ragu. You substitute Prego or Hunt's for Prego. In the case of if you're consuming Ragu, once again, still substitutes all the way around. So all the values not on the diagonal are positive, indicating that all of these products can substitute for each other as price changes. But what we can see is that some substitute more than others, right? People still have preferences. And where we see this the most is that an increase in the price of Ragu, spaghetti sauce, has a larger impact, right, than a change in the price of hunt sauce. And having eaten all three of these, I can tell you it's probably because hunt sauce is the most basic of the three, and maybe more consumers don't want it, shall we say. It's the cheaper of the three varieties in most grocery stores. So a 10% increase in the price of Ragu spaghetti sauce increases the demand for Hunt spaghetti sauce by 5.3%. But a 10% increase in the price of Hunt sauce increases the demand for Ragu by only 1.4%. Once again, makes sense if you realize that Hunt's tends to be the cheaper. So even if they raise their price, it's still not that much of an increase. So what you're really seeing is consumers who view Ragu as more palatable, but they like the price of Hunt's. When if Hunt's raised their price, they'd say, I'll just pay the little bit more to go to Ragu, right? It's worth it to me to change now. So earlier we said that price flexibility is the reciprocal of the own price elasticity. So if the calculated elasticity is 0.25, which is 1/4, then the price flexibility would be 4, right? 1/4, the reciprocal is 4/1. So this concept's useful to producers when forming expectations for the current year. If the USDA projects that there's an additional 2% of supply will likely come on the market, then producers know that the price will likely drop by 8% when that occurs. That's really helpful, right, from a calculation perspective. So price flexibility, when the own price elasticity is elastic, then cutting the price will increase the revenue. Increasing price will decrease, right? We've seen this before. Once again, with characteristics of agriculture, we tend to have inelastic price elasticity, so we know we're going to see a decrease in revenue if price goes down. And that's where we're calculating that if price increases by 2%, then we get that 8% fall in prices. So this is the changing price response over time. Remember at the beginning of this presentation, I said that one of the things we can look at as economists is that as time changes, goods become more elastic, right? Demand becomes more elastic because consumers have time to respond. And so this becomes what's known as a recognition lag. So when price initially changes, people don't know what to do, so they keep buying what they've been buying. As the price sustains at a higher level, let me give you a real world example. One of the things OPEC, the oil producers cartel, is worried about, OPEC Plus, is that if the price of oil stays too high for too long, it will generate more and more people switching to energy efficient cars or even battery powered cars. And they don't want that to happen. They want people to consume oil, since currently transportation still is one of the #1 usages for oil. And so OPEC in the past has been very reticent to allow prices to sustain at high levels for super long unless they can't stop it from happening. So OPEC says, look, if price is above $100 a barrel, the gas prices become so high, we see a large rate of consumers switching their vehicles, and that means that gasoline demand and petrol demand drops into the future. And in fact, we know this has been happening because gasoline demand in the United States, even though there's more people, more cars on the road, has actually fallen for the last 2 or 3 years now, right? So we're using less and less fuel. And that's because prices sustained at higher and higher levels, and people swapped for more energy efficient models. Also, there's government mandates that were mandating more energy efficient models. So if we have ag's inelastic demand curve, once again, a small increase in the supply, the quantity supply, will cause the price of the product to fall a lot more sharply. This situation explains why major program crops receive subsidies from the federal government, because farmers are left susceptible to huge price swings when there's very small changes in market supply that they really can't control for, right? And they can't account for. It's an unknown. And so we'll talk about this when we get to government regulation and we talk about crop subsidies and the way that the US government uses that policy to smooth out production over the long run and to ensure that we meet our security needs of producing food for ourselves. So while subsidies increase the cost of government programs and the budget deficit, they also benefit consumers from cheaper food costs, and the consumers benefit with a larger change in consumer surplus. So in summary, you guys can pause and read that, but that's what we've accomplished today. Let me know once you start the homework. I can go through some examples of doing these calculations. I left them out of the longer PowerPoint so that if it was needed, I could create a smaller PowerPoint next week to really go over those examples to bring it home for people. But I have a feeling it might not be needed. Just in the past, once you start working on these problems, you realize they're not really that hard. It's just division, and it's accounting for the correct numbers in the correct location. But as I said, please shoot me an email or text or post on Canvas if you'd like step-by-step instruction on a walkthrough of some of these calculations. So thanks a lot for your time, and thanks for coming and watching, and I'll talk to you later.